All right, so today we are going to discuss how to add memory to our AI agents. Okay, before that, let's quickly see what we have done in the past. So, this is our third session on the agents. Okay, this is some other deck. But anyway, we majorly understood what are agents. Okay, what are agents and what is the React pattern, which is one of the design pattern with which we build AI agents. So we saw that when we are building agents, how they are different from usual chatbot applications. Correct? In the chatbot applications, we ask the question and the large language model produces the completion and we get the response. But when we are building agents, they basically make the applications more complete in the sense that we force our large language model to be used as a brain, right? And when we build simple chatbot applications without the capability of agentic AI, what happens is it can only use the power of large language model. That's it. So since we know large language models are initially trained and they have their cutoff date. For example, if I'm using a GPT model like GPT-4o mini, maybe its cutoff date is January 2024. So any incidents or whatever which happened after that cutoff date, the LLM has no information about it. Correct. Secondly, we have seen if we want to do some heavy calculations, maybe the multiplication of 5-digit number to 5-digit numbers, then your LLM will not be able to do that. Similarly, if you want to find out the weather of any particular city as of now, then again LLM will not be able to do that because it has no way to interact with these APIs. So that's how we started, building the agents. So agents are basically the AI applications where we use large language model as a brain and we try to use its reasoning power and we also equip it with some tools which help it to basically decide, okay, my problem statement or the user prompt is like that, and it will first break that particular task into subtask. It will pick the first subtask and it will see, okay, in order to accomplish this subtask, maybe I need to call this particular tool because LLM itself is not able to do that job. So it will make use of some tools. For example, if the user is asking what is the temperature right now in the New York, so maybe it will call the weather API. If the user is asking whatever whatever be the temperature of the New York City, multiply it with some maybe 5, then LLM will come to know, okay, now after finding the temperature of New York, it has to use some calculator tool, right? So like that, we can make some more typical applications which are more powerful, which can use the brain of the large language model, the reasoning power of the large language models, and that can happen with the help of this React pattern, which means there is a thought process which go inside our large language model, and it will say, okay, uh, for this task, maybe I need to take this action. So it will choose one action or one tool. So we thoroughly seen what is the function calling. So it will choose the tool which is the best one to do this task, and then we will basically execute that particular uh, tool. Once the tool is called, it will produce some observation, some output, right? That output will be brought back to my large language model to decide what should be the next step. And then if it feels, okay, I need to call another tool, then maybe this loop will continue until my job is accomplished. Okay, so this is the basic concept behind these agentic applications. Okay, this example we have seen several times. We build our system prompt in such a way, we instruct LLM that you have to work in a loop or a cycle, which is like thought, action, observations, and things like that. So it will keep on using the different tools It will interact maybe with the search Wikipedia, maybe with weather API, any API or any website or anything outside world. It can interact with basically with the help of some tools. And tools are what? Tools are nothing but they are just the Python functions which are capable of doing anything. Okay, now we can, with the help of these, we can make some complete applications, right? For example, some real life examples. For example, I need to build some customer support which can resolve complaints end to end, uh, managing schedules, drafting emails, automating repetitive tasks. If I need to do a research, I can do that by using the agents, right? So we can build different agents for different areas. Okay. If you want to see some typical examples, maybe I want to build a traveling agent. So what that agent can do, a user produces details of an upcoming trip to a travel booking agent. And now this travel booking agent automates the booking of flight tickets and the hotel reservations. Okay. Earlier, what we were doing, we were just asking when we were building just chatbot applications, simply chat applications, what they were doing, we were giving some instructions to the LLM and it was giving me some output. Correct. I was just asking, tell me the maybe the flight tickets or tell me the hotels in the Mumbai. So it will give me maybe the information of 10 different hotels. But it was not acting. Acting in the sense it was not doing any action. It was just giving information. By building agents, what we can do, we can create applications which basically act. So not only it will give me the information of flight tickets or hotel reservation, it can actually book those tickets for me. So it will automate the task. Okay, the travel booking agent initiates an expense claim, right? After doing this task, booking flight tickets, doing hotel reservations, what it can also do is it can, if you build such functionality, that it can also initiate an expense claim for the travel cost through the expense agent. Okay, the expense agent submits the expense claims for processing. And the the capabilities are really limitless. It depends on how you want to build the agent, what you want the agent to do, how you want to control it. Right. So this is one typical example of building this traveling agent. Similarly, if I want to make just a claim, expense claim submission, so these are the different steps. A user asks the expense agent a question about expenses that can be claimed. The expense agent accepts the questions as a prompt. The agent uses a knowledge store. Okay. Some maybe some RAG basically containing the policies. It will give you the information what kind of claims you can basically put, whatever claims you can submit, what is the limit as per your grade and all. It can give you all that of information which is there in your policies. The grounded prompt is submitted to the agent's language model to generate a response. The agent generates an expense claim form, expense claim basically on behalf of the user, and it can also submit it to the to be processed and generate a check payment. Right. So when it comes to basically doing the action and delivering some output, then we build these agents we can which can do end to end a particular task. Okay. So that was why they are important. We have already covered all these things, right? And then we started building our
So basically,
yeah.
Surendra, agent
Mhm.
is an extension of automations in a
Exactly, you
way.
can say. When we do automations, it's a type of automation, but the main difference between automation and agentic applications are that if we upfront know whatever agent is, what kind of automation we are doing, or we can derive the rules basically, that will be a rule-based automation, isn't it?
Yeah. Yeah. Yeah.
If I already know from A to B and from B to C and from C there are two routes, maybe D or E based on some conditions, then those are called basically workflows or rule-based workflows basically, which we can in fact do without using these agentic AI. Correct? I can draft those rules. But if I'm building such an application where I want agent to decide dynamically based on its, reasoning power to take some action from the given set of tools, then we say this is an agentic application. So there is a minute difference between these two.
So
but
in a way,
yeah,
if there is an
in a way it's
automation,
an automation. Yeah, yeah. In a way it's an automation
yeah,
only.
means let's say we create an automation in the company only,
Mm-hmm.
and we use some LLM over there to make decisions, let's say on KPI deviations,
Mm-hmm.
and then highlight certain things based on that. Right. First of all, it's LLM learning is done, and after that,
Mm-hmm.
it's providing the deviations,
Mm-hmm.
right,
Correct.
by calculations. So that also becomes a agentic means application.
Yes, yes, yes. See, I mean, this definition is very broad, right? Even
Yeah,
if you are using some RAG and you are also using some one tool, then also people start calling it an agentic AI. And the definition also varies from provider to provider, right? Cloud may have some different definition of agentic AI. OpenAI has some different. But all in all, I have explained you the main motive and the main rationale behind the agents, right? How they are different from usual applications. But in a layman's term, we start calling everything as an agent, right? Even if I am doing a RAG, if you have used this Microsoft Studio for building agents, even if you build a, I mean, there's an option to create the agent. In that agent, if you simply give one PDF document and you create a vector database, that is also an agent basically, which everyone in the enterprise can use, right?
right. Yeah. Thank you.
All right. So that was on the basics of this agentic AI. What is that? And then we covered some basics of the LangGraph, right? So LangGraph is again another framework from the LangChain, which help us to build these agents. There are other frameworks also in the market. For example, N8N. That is also one of the famous framework, right? Let me show you that also. N8N is a platform automate workflows with the AI. Okay, so this is really, this is something which is you just use this canvas, you just drag and drop, right? Anthropic chat, and then this is your AI agent. So you basically drag and drop. This is low code, no code kind of, I mean, platform where you can build your agents very quickly. But again, what we are doing is we are learning LangGraph because LangGraph agents are basically built by coding, right? So that's a difficult route, but that's a flexible route. So from this NA10, you can only build those agents for which you already have the plugins and you are not basically writing the code. So you have less flexibility, right? With the line graph where you are basically coding yourself, you have more flexibility in your final product. Okay. But if your use case is basically falling under one of the use cases which are being explained by N8N, right? All the plugins are already present and this is the best fit, right? You are doing basically something which they have already implemented, then it's good to go with N8N. But if you are building something new, something which is not being covered by N8N or any other platform, then I think the best product is the LangGraph, which is again coming from LangChain, where you basically code. So if you understand the LangGraph, how it works, that means you also knows how this N8N and other platform works behind the scenes, right? Here you are not basically controlling everything since you are not writing the code. But if you understand LangGraph, which I have been explaining, then you can typically understand any other framework because this is one of the toughest one, hard to understand. But once you understand, then it's very easy to build the agents which are quite flexible and you can, in fact, can do anything you want to do. Okay, so we have seen this LangGraph agents, what is the LangGraph, how to set up LangGraph. We installed all the libraries and we saw these are the different other frameworks for building agents. Okay, and we have seen what is start node, what is end node. All these rectangles are basically called nodes. and we connect these nodes with the help of edges. So this is like an arrow. This is the starting node. This is the assistant node. The node is typically something where some processing happens basically. So this node
I
can
suppose
be
Madhu can switch off the video.
yeah. Anyone who wants to switch off the video, please switch off. Okay. Okay. So we have these nodes where the processing happens. Maybe we are calling the large language model. Maybe we are executing some Python function, which is called tool calling. So what happens is we basically create one state object, and that state object basically travel through all these nodes, which are processing units basically. And the state of that state object keep on changing, right? So let's say this is a large language model call. So there will be user prompt with the instructions what you want to do, and with that instruction, or maybe we also have a system prompt, the LLM will produce some response. So that response will get appended to my state. That entire object will go to my tool. It will read the last message and it will do some processing. It will go back to my LLM node, right? So that state basically keeps on changing through the entire life of it in the workflow. Okay, and we started building these simple workflows, node 1, node 2. Then we started looking how to put deciding nodes, right? Where you have to decide whether it has to go to node 2 or node 3. This is the nodes basically. Okay, and these are conditional edges. They are shown by dotted lines. And then we started using the tools, right? What is tool calling basically? So we have seen when we call any large language model and we associate it with a couple of tools. Now the large language model can use those tools, but it only decides the name of the tool and the parameters which we have to use, but it will not basically call that tool, right? It cannot execute that function. It will just tell me which tool, right? If I associate 5 tools, it will tell me, okay, you have to use a third tool with these parameters. Okay, so we have seen how to create those large language model nodes, and it will basically, and we saw how to use the out of the box functionality of tools node, which will call the tool also automatically. When we initially created our first Python React agent, we were executing those tools manually. But now with the help of LangGraph, that tool calling is automated, right? So if we have 5 tools and the large language model decides, okay, I need to call my first tool, so it will come to the tools node. My function will be executed, output will be brought back to LLM node. Now it will say, okay, I need to call tool 3. So it will go on, right? So this loop basically, which we, it's basically a React loop. Okay, it will do some reasoning. It will decide a name of the tool. The tool will get executed automatically. It will produce some observation. So this is that loop which we initially studied, right? Now, but there is one problem, right? In this, the major problem is if I'm invoking my graph or my workflow, then what will happen after my invocation? All my messages are lost because this is not persistent. So now the biggest question is how to make my agents persistent so that they can store the messages, right? The messages were stored for one execution, but now if I'm calling it again, they are lost basically, they are overwritten. So how to retain that? That's what our agenda is for today. I hope everyone is clear. Let me tell you again what we are trying to achieve, right? So we built React agents. They had no memory attached to it. Now, so we have to save the entire conversation into some database, right? So if that is the condition, what we have to do, we have to save our conversations into some database. But instead of doing that, the LangGraph has give us one mechanism to store that into the memory. Okay, and we have 2 motives basically. One motive is to remember the previous invocations or the messages. Okay. So what we'll do, if I invoke my graph one time, maybe 5 messages are produced. Now, if I invoke it again, those 5 messages will be retained basically in the memory. And if I say add two numbers, 2 and 3, okay. Now, once it adds the number, my again prompt is now multiply the result with 6. Okay. So how it is possible? That is only possible if my previous messages are retained in some memory. So that's what we are going to see today, how to save those messages of one execution or multiple executions. Second thing is, let's say there is a user 1 and there is a user 2, right? For example, if you use ChatGPT, what happens? You might have seen whatever conversations we have in the past, they all are saved here, right? Python dict versus, correct? So why I'm seeing all these my past conversations? Because there is some ID associated with these conversations. So I can pick any one of these basically, right? And I can start having conversation on top of it, right? If I say CA stomach reasons, now if I ask any question, all my previous history will go along with my prompt, right? So they are basically different conversations, right? So there are two things. One is like different conversations, maintaining different conversations, and the other thing is maintaining a lot of messages in a single conversation, right? So both things can be achieved with the memory. Got it? So I will directly jump to the code. I was working yesterday on it. सभी को clear है, right? What we are trying to achieve, guys? Or
Yes.
yeah, so maybe I will explain it again with the help of code, right? So now whatever we will do, that is basically a bit code heavy.
So is it the same functionality that we are having in the chat GPT? Are we trying to
Yes, 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 yes. I mean, ChatGPT may be doing it in some different way with
Similar.
its, but the concepts are same, right?
And can I attach any duration, like till this time it will be saved?
Duration. See, right now, whatever conversation we will do, they will remain in the memory and for this session only, right? Duration will come into picture. For example, if we want to save those in the database, in that case, we need to save the conversations into some database basically. Okay, and then definitely we should have some TTL kind of setting. What is time to life, right? Maybe we
Like,
want only the 2 months history, or because eventually what will happen, the amount of information will keep on exploding, right? So that also we
yeah.
will cover how to manage when we have multiple messages. For example, if you have 100 messages in the past and now I'm typing 101 message, does that mean that all those 100 messages will go along with my new request? That will, that is the case. But what about my cost? It will cost me a lot, isn't it? Every time
Yeah.
I'm passing those 100 messages, and since you know the how the cost is calculated, anyone can, the cost is not the LLM cost is not calculated on the number of calls, rather they are calculated on the number of
tokens?
tokens. Exactly.
Tokens.
So if my messages, number of message will increase, my cost will also increase. Correct? So if I ask even a simple question which has no relevance to my historical chat, it will cost heavy because all of it will go into my request and they will be counted as my input tokens. Okay, so in order to avoid that, what we can do, we can summarize our past chats. Okay, instead of 100 messages, what I can do, I can send them 100 messages in one go and I will ask my LLM to summarize those, right? And this is exactly same as how the human beings behave, right? Let's say I talked to Muhammad maybe last week. Okay, we may had we may talked about maybe for 30 minutes, but if you ask me today, what was the points of conversation. Maybe I will be able to tell you, maybe in the 2 or 3 lines, this is what we talked about. Maybe we talked about H1B visas or something, but I may not remember each and everything. All I will remember as a human being is just the summary of it, isn't it, guys? I will not
Yeah,
be able to
but
remember every word to word, but in my mind there will be some summary. Okay, I talked about H1B visas. The fees has been hiked or something like that. Yeah, please. Someone was asking something.
yeah, so I want to give one specific example. Like 6 months back, I shared very detailed information about something,
Mm-hmm.
and for another 2 3 months, ChatGPT was able to give me. Okay, one
Mm-hmm.
more thing. I used my Gmail ID to log into the ChatGPT, so I
Mm-hmm.
was using the same account. Uh, After 6 months or 9 months, I asked, like, can you please tell me what are the medicine I have told you for this skin disease and all?
Mm-hmm.
ChatGPT was not able to recall.
Mm-hmm.
ChatGPT told me that you have to tell me again what are the medicines you told me earlier.
Mm-hmm. So
Then
so
what is
it
the purpose of using machine? Then there is no difference between machine and human, right? That's why we use machine, so that
no, I mean,
it saves the
you had that conversation in the left hand side as I'm showing on the screen. You had that conversation where you talked about the medicines for the skin in the left hand side, or not?
that
If
I
it
don't
was there,
recall.
I mean, if you simply start a new chat and ask anything, that it will not be able to understand, right? If you start a new chat, it has nothing to do with all your previous conversations.
But altogether, it's going to ChatGPT, right?
Yeah, I
Which is
mean, they are
attached to
going,
my
but
Gmail ID.
they have different threads, no? If you
Okay.
ask any one question, how it can basically see, LLM is just a machine which has no memory. So whatever question you ask every time, it's an independent question. So it is able to understand my previous messages only because I'm sending it in my current request, right? That may be as original messages or maybe as a summary, right? So
Got
if
it.
I'm
Got it.
asking a new chat, then it will not send all these things, right? Otherwise, my cost will be very heavy. Right? If I want to ask anything on top of my previous, I have to select that particular chat, right? Then only it will send. And then all these things can be basically, can be controlled by these things, right? If I don't want to save anything, that is also I mean possible, right?
Yeah, I don't recall it, what category I have selected. But I got the
Mm-hmm.
answer. Thank you, sir.
Mm-hmm.
Yeah. Thank you. Thank you, Surendra.
Yeah, data control, right? Shared links, delete all chats. If I want to delete all my past conversations, I can delete it basically. Improve the mode. You can also switch it off. If you don't want to share your information, you can just switch it off. Usually, when we are using on office laptops, we keep this thing off basically. We don't want to, you know, want ChatGPT to use our information. So archive, all these things are there. Okay. Anyway, so let's move back to our. All right. So let me. Name of my virtual environment is VENV. Let me activate. My environment has got activated. So I have already installed some libraries like LangGraph. I need LangChain, and I need LangChain OpenAI. Okay. So what I'm using is right now I'm using my OpenAI account. Okay. So I have put my key there, and I have installed these libraries, LangGraph, LangChain, and LangChain OpenAI, and I also installed python.env. Okay, only these four libraries are required. So what you need to do is create new virtual environment and install these four libraries. Once you do that, I will share this particular notebook. So add memory to the same agent. In order to add memory to the agent we previously built, we need to do first compile the graph with a check pointer. Second, pass a config object. Okay, so let's first load our environment file. And these we have already discussed. From the line graph, we are having this state graph, which will have my state of my graph, start node, end node. This is the message state, right? So what the message state is? Message state is basically my typed dict object, which will have a key called messages, and it will have list of messages, and it has a reducer basically, right? So they have already done all these things in their library, right? The code which we are seeing right now, it's being written by LangChain. Okay, so they have created this class which is called message state, and it is having a key called messages. That means typedict means it will only have the messages kind of objects as its value. And the beauty is that, which we discussed in the last class also, if you are using this message state, whatever messages or whatever response I get from my large language model, it will automatically get appended to my messages key. Okay, it will not replace the existing message, rather it will append to it. How it will append? They have written that logic in their library. Okay, add messages, for example. Okay, so it will add those messages automatically. We should not be bothered about that. Okay. Mm, just give me a sec. Sorry. All right. So this is the library which we are going to use. This is having a reducer, okay, which will help me to add the messages automatically. Okay, we'll see it. And we are using chat OpenAI, LangChain underscore OpenAI, and this is the tools node. This is tools conditions, which are again out of the box functionality, which to execute the tool, and this is to decide whether it has to route to the tools node or not. Okay, everything has got automated. That's why we are using this LangGraph as an framework. Now I have two different tools. One is the multiply tool and other is the summation tool. Okay, and I have also given the signature. The input parameters are of the float types, and the output is also a float type. These are very important. It will help large language model to decide which tools to call and what parameter to set basically. Okay, and this is my doc string which tells what this function is doing, what the about the arguments and the return type. Okay, so you have to craft it very carefully. So I have two different tools. One is the multiply, other is the sum. I have put these into my tools list. Okay, and this list basically I will bind with my large language model. Initially, I created this LLM object with just using chat OpenAI. Model is GPT-4 mini. Now I am telling LLM that you have access to these tools as well. This is very important. So there is a LangChain method called bind tools. We are binding LLM with these tools. Okay. Now this object, which is LLM with tools, we can use it. So when we build our graph, we first define our node. Our node is LLM node, which will take my messages state as an input, right? We used the LangGraph messages state, okay, which will have the key messages, and it will keep on appending messages in that particular key. And what we are doing is we are invoking our large language model. As you know, LLM with tools, this is again a runnable object. So we can use dot invoke, and we are passing the value of these messages. Okay, fair enough. When all my messages are passed to my large language model, it will produce some response. And this response I can simply pass return in the messages key, right? So as I was telling, so returning messages colon response will not replace the existing messages in the message, rather it will append this response to my existing messages. Okay, this is very important. Okay, if I had system message and a user message, then whatever response I will get, it will add that response message also in my messages key. so that it will have the list of all the messages. Okay. Up till this, we have already seen. So this is same as what we did in the last class. So I have my LLM node. This is, I am defining my state graph with the messages state. And my first node I'm adding is LLM node. This is my literal name of the node, and this is the function. And then I'm after LLM node, I'm adding my tools node. Okay. This is again out of the box node. This is the name, and this is the actual tool node which we have imported, tool node. After defining or adding these two nodes, we have to define the edges. So I'm saying from start to LLM node, this is one edge, which is joining start node and the LLM node. My second is the additional add conditional edge, which will go from LLM node to the tools condition. Okay, and from tools to LLM node. If you compile it, you will see. Let me run it. Done. So this is the graph basically. Okay, so till now there is no change. We have not deviated from what we did in the last class. So this is my graph basically. This is start node, LLM node. If LLM node is telling me I have to call a tool, right? So based on the last message, it will go to the tools node. It will execute the tools. It will give me the response. Okay. And then if it has to call another tool, then again it will go on. If it feels no more tool is required, it will end basically. Okay. Anyone has any questions? Till now, we haven't done anything new. Now, the problem is if we execute this particular graph, first time it will get executed. Second time, if we execute, then all my previous messages will be lost, right? So what we can do is there is something called memory saver. Okay, so I will do from langgraph.checkpoint.memory import memory saver, and I will instantiate it. Okay. And there is something called the check pointer. This check pointer will basically help me to save the state of my graph into this memory basically. Okay, so that in the future, if I want to resume same graph, I can use this check pointer and I will again start invoking my agent. Okay, I will explain you what does all these things mean, but I have instantiated this memory saver and I'm assigning this memory to my check pointer. So while compiling it, I am providing this check pointer is equal to memory parameter. So this is different from what we did earlier. Okay? Earlier we were doing simply builder.compile. Now we are doing builder.compile and we are also giving it, okay, we have a memory object. There it has to save its state. Okay, now let's say my messages, I'm saying what is 827043 times this much. Okay. So what will happen? Based on my question, my tool node should be able to decide that I should use this tool, multiply tool, isn't it? So it will come here, it will pass those parameters, multiplication will be done. It will send back the response to my large language model node. Okay, let's see that. Also, now I am defining my thread ID. Okay, as I said in my chat GPT, all these are basically my different thread ID equal to 1, thread ID equal to 2, so on and so forth. So these thread IDs basically help me to define the conversation. Okay, let's say a user is having conversation with the agent. So for that user, maybe the thread ID is equal to 1. Okay, so that whatever conversation is being saved in my memory, that will be against thread equal to 1. And while invoking my graph with the memory, I need to pass one config object. And it has a key configurable, and I will pass the simply thread ID. I hope this makes sense. All I am doing is I am defining my memory, okay, whatever conversations we have, they have to be saved in the memory saver object. And I'm defining a thread ID in order to distinguish between various conversations which are going on. And while invoking my graph, I will pass that conversation ID, right? If I want to continue this chat, maybe I will pass thread ID equal to 4. This chat maybe thread ID equal to 10, like that. Then only my agent will be able to retrieve that conversation from the memory. Let me call it. Okay. So I use the thread ID equal to 1, and whatever the result which was produced, let's do pretty print. If you do the pretty print, I can see my human message. My first message was what is 82703 multiple times this number. And as we expected, this is a tool call. My LLM said, dear, you have to use this multiply tool with these two arguments. Okay, this is what my LLM is producing. It's not invoking or executing that function. All it's telling is this tool should be invoked. Now I have this tools node which will execute this tool. Tools message multiply. And what is the observation? The output is this. Okay. So if you calculate this yourself, 827,043 multiply by 16458 13611. Okay, 694. So it has done the multiplication very well. So the final answer LLM is producing is 8 2 times this much is this number. Okay, is it clear? Now, if my further question is, my next question is add 6 to that. All right. So now my LLM can understand this that only if it has access to the previous messages. Okay. And the previous messages were saved in the memory with the help of thread ID equal to 1. So I will invoke the graph again, but with the thread ID, which I assigned earlier, right? This thread ID value is 1 only. If I make it 2, it will not be able to answer me, right? Because for thread ID 2, there is no history. So it will not be able to understand to which number it has to add 6. But now I'm using the thread ID 1, it will be able to do that. So if I print my messages, I will see, I can see the history of my earlier conversation also, right? My first invocation to the agent. What is this times this? The tool call, the final answer. Now the human said on top of it, add 6 to that. So it will add 6 to this number basically, because it has same thread ID. So again, this time which tool will be called? The sum tool, not the multiplication, rather the sum tool will be called, and 694 plus 6 will be 700 basically. So it has done the 700. Okay. Adding 6 to this number gives you this number. Is it clear or not, guys? So on top of it, if I do something like if I call my agent,
Surrender,
yeah.
this is Jagdish. I have one question.
Mm-hmm.
So these kind of the small calculation or a small thing, it's also one of the server, whatever is our running code. It is also capable. Why again we can ask for the LLM? Is it
Okay.
possible we can utilize our computation because of the whenever we can running this agent, that is
Mm-hmm.
also have a compute. Why
Mm-hmm.
we can again always we can go for the LLM? Is it possible we can utilize because some of the small calculations, some of the small thing we can do that at our end as well. Is it?
Mm-hmm.
Mm-hmm.
So this is just an example, right? This is a toy example,
Mm-hmm.
right? That's
Okay.
why we are trying to explain. If I say what is the temperature of Delhi right now, so we will not be able to do it ourselves, right? So we have to call
Mm-hmm.
some weather API. तो वो
Mm-hmm.
कौन करेगा? Our LLM will only do it.
Mm-hmm.
Right? LLM will decide, okay, he is looking for the weather, so I should, let's say I say book my ticket or book my one room in the Taj Hotel in the Mumbai. So what it will do, it will call some other function or some Python
Okay.
functionality.
This,
Hmm.
This is a understand, but some of
हाँ.
the some small calculation like some we have to some two number something small
Mm-hmm.
kind of we have to bind the you can say messaging something. These
Mm-hmm.
kind we might be possible we can utilize our like agent where is running the agent which server we can utilize. Am I right?
Yeah, I
Not
mean,
always we can go for the LLM. Some of them which are we can do that. We can
mm-hmm.
do the our own. Some of them which are not possible in our compute server side, then we
So,
can go for LLM.
so how you
Yeah.
will? No, so LLM is not doing the multiplication, na? We are only doing it, isn't it?
Mm-hmm.
LLM is just telling me you have to do the multiplication. LLM itself is not able to do the multiplication. It's not
Okay.
trained. It's not trained that way that it will do the
Mm-hmm.
multiplication.
Mm-hmm.
If I ask LLM to do, LLM will give me wrong answer. Let me show you.
Mm-hmm. Okay.
So
That's good. Then.
where is my LLM? This is my LLM without tools, right?
Hmm.
If I use this LLM, okay. So this is the result. Okay. LLM now LLM has done this. If I go to the calculator, or maybe we can check by simply 3, 6, 18, right? So 18 is 8 is there. Let me do it fully. 1, 2, 3, 2, 1, 3, 4, 5, 6 multiplied by 4, 9, 8, 6, 7, 3. Answer is 61443. Your answer is 61405. So LLM is not able to do these multiplications, right? And we don't expect it also because LLM is trained to predict the next token, next sequence, right? Are you getting? That is the reason why we are not asking LLM to do this, but rather we are saying, हमने वो Python function लिख के रखा हुआ है, how to do the multiplication. You use that function and get it multiplied. Why you are taking the load, right? That's the whole point. LLM cannot do the
Surinder,
multiplication. Yeah, tell me.
I have one question. Can you please go to the place where you are asking for the that sentence to add
Okay, this one.
in the mem? Yeah, in the next level, we're going to add to the
हाँ,
multiplied number.
add to that. This one.
So add 6 to that. So
Hmm.
I mean, this is going very high level, like because we are just telling to add 6, right?
Hmm.
And by itself, it will understand that we're asking the code or API to, I mean, recall the multiplied number and
Hmm.
add 6.
Hmm.
I mean, can you please describe this sentence how it is calling
Yeah,
in
yeah,
the
yeah, yeah. Just a second. Yeah.
AI level? Because it is double coded. Add 6 to that. So if I understand layman language, it is just from the concept of C or Java, it's a hard coded, right?
Sorry, I got a call. Sorry, sorry. So you were not able to understand this particular thing, is it?
Yes, yes.
How LLM was not able to understand that? How it is able to understand what is that basically?
Yes.
I mean, that's what we are doing it today, right? How to make our conversation persistent. That is happening because our previous invocation was done with the thread ID equal to 1.
Yeah,
Okay.
that's
And
correct.
this
Yeah.
and this and this memory, basically memory object helps me to save my states of my graph to this check pointer or this memory in the, I mean, layman's term, it is saving my memory, all the messages into my memory basically. ठीक है? First time we invoked it, we did multiplication. Whatever messages were created, they are saved in this memory, and they are saved with the reference thread ID equal to 1 has these many messages. Okay.
Yeah.
Now
Yeah.
second time I'm saying add 6 to that, and I'm giving the same thread ID which is 1. Okay, right now the
Yes.
value of this thread ID is equal to 1 only.
Yeah.
Okay, so it will understand, okay, this conversation is for the thread ID 1, it will pull the previous messages from the memory, and on top of it, it will add this message, right? That is why when I'm printing the final messages key, right, which is there in my state object, it has all the 6 messages, 3 from the previous one and 3 from the current one. है ना, इसके पास ये सब है पहले से thread ID 1 में. That's why when we say add 6 to that, it is able to understand, okay, to this number I have to add. It has access to all these messages.
Yeah, maybe I'm a little slow, but this is
Others are able
very
to
advanced
understand.
level.
Others are able to understand.
See, the thread ID, defining the thread ID, let's say 1 is okay,
Hmm.
right? That is understandable. But
Mm-hmm.
the thing is currently referring to add that, right?
Mm-hmm.
We have coded that,
Correct. Yes.
है ना? So
Hmm.
how it will happen dynamically?
Dynamically, whenever you are, see, whenever in ChatGPT, if I say new chat, what will happen? One new ID has got created and associated with this new chat. Whatever I will type, those will get saved into my thread ID XYZ, whichever has been. If I go back to my other conversation, once I click here, that ID, that other ID which is associated with this chat has got generated. When I say something, it will go to that into that thread ID. Right now we are doing the backend coding, right? We are not doing the front end coding.
Yes.
Okay.
Okay. So
This is
those
how.
functions add
Mhm.
6 to that.
Mhm.
Those could also be dynamically defined.
Yeah,
है
yeah,
ना?
yeah, yeah.
Because it's
Mhm.
add for here, है ना?
Correct, correct.
Could
वो unique
be
ID,
anything.
that unique ID we will create by some logic, and we will associate it with the different conversations based on the user actions on the screen. है
Because
ना?
next time it could be weather. What's the weather in Delhi?
Yeah.
And then next could be if the weather is, let's say, 2 degrees more than what
Mm-hmm.
you defined or what you gave answer.
Mm-hmm.
है ना? So it will be a different and it may not be hard coded. तो ये
Correct.
डायनेमिक रहेगा फिर.
Exactly. ठीक है. अभी we are seeing how to build these simple applications. If you bring it to the actual in the production, you have to also create your front end. You have to associate your front end user actions with these things. Correct. When he select a new chat, new ID should be created. With that new ID, your function will be called. Na? Here we are giving it manually 1 or 2. That point of time, it will automatically get created. ठीक है. Everyone's doubt is clear. Jagdish, you are also good. So we are not doing the calculation. Our LLM is not doing the calculation. We are doing it by Python function only. Normal
Yeah, good.
from
Understand.
normal coding only.
Understand.
But and
Surendra,
So Surendra, Nitesh here.
one question I have.
mhm.
Can we just try one? Can we just try one with the thread ID 2? What's the
Yes.
response we get?
Okay, so let's say I choose the same set of message.
No,
This
only the second question.
okay, the
Add
second
six to
question.
that.
Okay,
Add six to that, and we have a thread ID
got
with
it,
a
got it,
value of
got
2.
it, got
Okay.
it. So I will do like that. I make it true. I have to print the messages. Just these two messages. This is a
Yes.
new thread ID. So could
Mm.
you please provide the number to which you want to add the 6?
Right.
Got it?
Got it. Yes.
So
Thank you.
now my next invocation can be on any ID, one or two, right? So that conversation will go on basically.
Right.
Okay.
Right.
All right. So next topic is, let's say if I keep on doing this, you will.
Surendra, just
Yeah.
one question.
Yeah.
At any point of time, I can clear that memory also for a particular thread or particular user or whatever logic I am building for a
Yes.
chat memory.
Yes.
Okay,
Why not? Right.
okay. So do we have some method into LangGraph itself to clear that particular chat or
Yes. We are actually seeing this one right now.
acha,
Okay.
okay. Okay,
This
okay.
is, I
Okay.
So we
mean,
can,
pretty much, this is not exactly clearing the entire conversation, but yes, this is a matter of just one function, right? You can write one function which will clear
Mm-hmm.
your memory. It's as good as you are basically creating new chat, right? If you are creating a new
Okay.
chat, that means you have no history. If you
and
want to,
we can say,
yeah.
sorry, I'm sorry, I do not mean to cut off.
Yeah. So I'm saying if we are having the new chat, that's as good
Okay.
as we are
And
clearing the messages in
Vulpesh,
the current one. Yeah.
the token consumption is basically
hmm
okay. Got it.
Yeah. Token consumptions, basically your LLM cost is equal to input token cost plus output token cost.
Yeah. And in
Okay.
the like when we are building these agents, the
Mm-hmm.
token cost is basically initially like token consumption is when it's calculated. Now the tool has to be called.
Hmm.
Actual tool execution will not incur any cost, correct?
Exactly. Correct.
Okay.
Okay.
Yeah, what I was saying is we can
Mm-hmm.
set the TTL also, right? To
Yes,
the,
yes, yes, yes.
and for that we have to call a specific function or API.
Yeah, I mean, mm, so I mean, see, if you talk about ChatGPT, how ChatGPT is doing is ChatGPT is basically also saving these conversations into some database, right? So
True.
if I log in with my same account to some other laptop or from my phone, I will get all these conversations as well from
Yes.
there also. So what it is doing is it is saving all these conversations along with the thread IDs into some database. And when I log in with my this ID, Gen
Gmail
AI
ID.
cohort, it will go to that database. It will say whatever history is there, bring that history. It will bring all those conversations on my phone, and I will be able to see all these things again. But if I say, or if they have programmed it so that, okay, after every 2 months, they have to purge these conversations, they can write some code in their database, right? They can write some script there that all the conversations which are older than 2 months should be purged. They can write that, I mean, this is something which we have been doing, right? अपन जब database में we do all the records older than 10 years should get purged. That kind of script they can write, which will basically erase that data older than 2 months, right? उसका यहाँ से इतना कुछ लेना देना नहीं है, right? Why we want to do it from front end or from our application? We can write something at the database end. ठीक है? If someone wants to explicitly do it, he can just go and take some action. This will trigger some action and it will go to the database and it will wipe out the entire history for this thread ID, which is associated with this conversation. Got it?
Okay, sir. Thank you.
Yeah. चलो ठीक है. So I was saying the input token, जितने भी input tokens which are going as my request that are calculated with some different rate. For example, the rate can be $2 for my input tokens. Sorry, $2 per million tokens for my input tokens. ठीक है? For input tokens. And for output tokens, it can be as high as $10 per million tokens generated for my output token. ठीक है? For your information, guys, now there is a GPT-5 already in the market, right? The GPT-5 is, I'm just telling you something apart from our current topic, deviating a bit. This GPT-5 is basically a reasoning model by default. Okay. So whatever question you ask, basically it will do some reasoning. And the reasoning cost is again another cost on top of these input and output token, which is these days is called reasoning cost or reasoning tokens. Okay, so they will not be visible to you. What the reasoning means, whatever question you have asked, it may perform some chain of thoughts. It will reason, right? It will decide what to call. Should it call to some APIs or some other tool? It will reason behind, right? It will create some chain of thought. So whatever tokens which are generated intermediate inside the large language model, that also you need to pay for it. They will be added to your output token cost. Okay, right? So you may say, okay, my output was just that a single number, but my cost is high. Why it's so high? That is high because your output token, these reasoning tokens also account for your output tokens. So there is a method again. If you are using GPT-5, there is a setting called verbosity, and another is, I think, reasoning, where you can basically tell your model whether you want low reasoning, you want medium reasoning, or you want high reasoning. Okay, based on this setting, it will do less reasoning or more reasoning, so your cost can be controlled even while using GPT-5. Okay, within the GPT-5, they have like GPT-5 mini, GPT-5. There is one nano. There is one GPT-5 itself, right? So all these different models are there. But in general, the OpenAI is saying their cost is reduced. This is because if you are using ChatGPT with, if you're using ChatGPT, okay, that is on my different account. What will happen is the ChatGPT itself will decide based on your query to which model it has to route, basically. Okay. So it's not like that every simple question will go to my GPT-5, which is very powerful for reasoning. If your question is simple enough, dynamically ChatGPT is routing it to the nano one, which is doing reasoning, I mean very less reasoning and giving you the fast replies. If your question is a bit more typical, which needs more reasoning, it will go to GPT-5 mini. And if it's a research question you have asked, go to MIT website, or do some research, go to archive.com, then it will go to GPT-5. So dynamically it basically decides. You don't know to which model your request is going. ठीक है, चलो छोड़ो. This is about GPT-5. We
So,
Yeah.
Surendra, like, I mean, so we can say that Chat GPT-5, even if we ask a simple question, right?
Mm-hmm.
The Chat GPT-5 is little costlier than the normal ones.
Sorry, is fast.
Like costlier in the terms of
So
cost.
I mean, see, I mean that's what I'm saying.
It is a
It
straightforward
Yeah.
question, right?
So
Who is the prime
and
minister?
see,
Something like that. Like if we
right,
ask
right.
a direct
So
question.
see, I mean that's what I'm saying. If you're using, let's say, GPT-4, which is very costly, if you ask a simple question, who is Prime Minister of India? So that request will go to GPT-4 only, because you have selected GPT-4, and it will do unnecessary reasoning, and it will increase your cost. But with the GPT-5, what they have done is based on your query, dynamically it will decide this is a simple question. Let's route this to the nano one.
Okay.
So your cost will be reduced automatically. So overall cost get reduced, because sometimes people are unnecessarily using GPT-5 or 4, and they are asking simple questions, right? They don't know which model to use.
Mhm.
That is adding cost to them. Okay. I mean, this I am explaining you because in one of the assignment I am doing, there we have to upgrade from GPT-4o mini to 5 series, right? So there is lot you need to think which model to use, what settings you need to use for verbosity, what setting for the reasoning and all those stuff. If I am using GPT-4o mini, what is the best model in GPT-5 series, right? Because APIs are there for all these three. Okay.
Oh.
Anyway, let's go back to our topic. Give me a second. So now, as we said, we can basically store our conversations with the help of thread ID. This configurable key is there. This config object we need to send with our invocation, and we have to pass the thread ID. Now, let's say I'm passing this thread ID again and again, and at some point of time, I will have some 100 messages. So though all those 100 messages will go into my input request, and it will add to my cost unnecessarily. So what I will do is, just like human being just remember the summary of the conversations which held in the past. We can also implement same thing, that we can summarize our past conversations. Let's say I can define that, okay, if my message length increases to 10, whenever 11th message gets added, what I can do is I can call some function which will summarize my previous 10 messages, and it will create one summary, and it will uh, append append to my memory. Okay, so whenever I am interacting with the LLM, instead of those 10 messages, only a 2-line summary will be sent now. Okay, so those kind of conditions we can put and design ourselves, how after how many messages we want our conversations to have the summary. Great. Now let's create a chatbot that can have multiple conversations and remember them. This agent will summarize the conversation messages and send a summary to the agent along with the latest 2 messages. So what I want to do is, I want to leave the last 2 messages, and whatever which are there before those 2 messages, I want to summarize them and send it to my LLM. Okay, so that kind of logic we can put. The agent will then use this information to generate a response. This will allow agent to use LLMs to have a longer conversations without having to spend a lot of tokens. Okay, so now what we are doing is we are using the message state, the same object which we used last time, but now we are adding another key which is summary. Okay, so now I have 2 keys. One is out of the box messages key, which is anyway there in my message state, okay, which will basically have all the messages. I am adding another key which is called summary. It is of type string. Fair enough. 2 keys are now there in my message state. Again, what I am doing is I am defining one object. These are the same things: chat OpenAI system message. This is and this is my chat OpenAI LLM. Now I am defining a chat node basically, which will do state is my input. I will take summary from my state. Now my state has 2 keys, summary and the messages. In this node, I will simply say what is the value of my summary. If there is a some value assigned to the summary already, then what it will do? It will say, it will create the system prompt as here is the summary of the conversation earlier and my value of my summary. Okay, and in the messages, I will simply put this system prompt and the earlier messages. Okay. If there is no summary, that means maybe I'm starting for the first time, right? So it will just keep the messages. Clear, guys? Just I put the condition if the summary has some value or not. If it is having some value, then I'm giving the system prompt as here is the summary of my conversation and the value of the summary and my new messages. ठीक है ना? If I have some summary of my past conversations, and if I'm user is typing a new message, I have to provide the summary also, right? To the LLM saying that this is the summary of the previous conversation. That's what we are doing here. If there is no, that then it's fine. We are not bothered. Maybe the user is interacting for the first time. There is no summary existing. Cool. With those messages, I will invoke my LLM and I will return the response, which will automatically get appended to my messages. Simple enough. This is my one node. Another is my summarize node basically. What it will do? It will again take the state object. It will get summary. And what it will do is if the summary is having value, this is the summary of these conversations up to this point. Extend this summary by taking into account the latest messages above. Else, system prompt create a summary of the conversations up to this point. Okay. And then I'm using this human message, the summary prompt, and my messages in my state object. And I invoke my large language model. Okay. All I am doing is when I will run this graph, it will be like this. Okay. First, my chat node will be invoked, which will check if there is a summary or not. If there is a value in the summary key, it will use that summary to design the prompt for my large language model and it will call it. At some condition, what will happen? It will go to another node, which is doing what? It is doing nothing. It is summarizing some messages. Okay. While summarizing, again, it has two conditions, whether the summary has already summary of previous messages. If it is there, it will append the new summary to that summary object. If it is not there, then it will create the summary of messages and it will assign into the summary key. ठीक है? And then it will end. थोड़ा सा समझने में it may take some time, but if you sit for a while, go through the code, then you will be able to understand. ठीक है? So I have defined this chat node, which is invoking my large language model. If there is a summary, it will prompt, okay, you have this summary and this is the latest message from the user, and then it will respond. If there is no summary, no problem, whatever the user question is, that will be used to LLM invocation. Okay. At some point of time or at some condition which we have defined below, I will cover that. It has to call the summarize conversation node, where it will basically summarize my conversation and it will save it to my summary. Okay. If summary is there, summarize conversation, it will get first summary. If it is there, then the system prompt will look like this one. If it is not there, it will basically, because summary is also what we are creating with the help of LLM only. Okay, who will create the summary? LLM only will create the summary. But the advantage is not every time we are passing those 100 messages, but in just one go, it will summarize those 100 messages into one message, and that point onwards, we will use that summary. Okay. So I will get the response from my LLM, which I will use in my messages. Okay. And then we said, right, we will leave the last two messages and we create summary. So for deleting other messages from the messages, what I have to do, I have to use this function. Okay. This function will do what? It will help me to delete all the messages from the messages key, leaving just two messages in it. Okay. And whatever summary I will get, I will assign it to my summary key, and whatever messages which are remained after deleting all the messages and leaving just two, that will save to the messages. सबको समझ में आया कि नहीं आया? I know it's a bit confusing. Okay. So last is when it should go to my this summarize conversation node. For that, I am defining the condition. Whenever the number of messages in my messages key exceeds 6, it should basically go to summarize conversation node. Okay. If it is less than that, it will directly end. Let me execute this one. And then I am just stitching all these things with the help of add nodes, edges, start to chat to this condition. This is conditional node. This function will be invoked. It will decide whether to go to summarize conversation or to the end. Okay. And from summarize conversation, I definitely want to end. Okay. Summarize to end, chat to either summarize or directly end. This is my graph. some exception. Internet connection. Okay, for the time being, I just commented this line. Let's see if it works. Now, when I call my graph, what will happen? I'm choosing a thread ID 1. In my config object, I'm setting that thread ID to the thread underscore ID. My input message is hello, my name is Giovanni Giardio, but everybody call me Giorgio. Okay, this is my first message. And when I invoke my graph, this will be my result. If I print the last two messages of my result, or maybe I will do it one by one. Let me call it. Okay. So since I called it for the first time, what will happen? My messages will have these two messages. Hello, my name is Giovanni Giorgio, but everyone call me Giorgio. Hello, Giorgio. It's great to meet you. How can I assist you today? Okay. No summary, nothing. If I call it second time, what will happen? I'm just asking what is my name. Since I'm using this config object, it should be able to tell me. Okay, what is my name? Your name is Giovanni Giorgio, but you prefer to be called Giorgio. Good enough, everyone? Now, up till now, there is no role of summary because I just have how many messages? 1, 2, and 3 and 4 messages. Okay. Now, if I call, let me show you all the messages. So right now I have, okay, I called this entire agent again, right? So now I have 6 messages. Hello, my name is this one. Okay. What is my name? It is able to tell me my name. What is my name? Your name is Giorgio. Total 6 messages. Now if I call it again, let me again remove the last 2 messages. I want to print all the messages. So now it's printing just last 2 messages. Do you know anything about me? All I know is your name is Giorgio and you prefer to be Giorgio if you would like to share. So why there are just 2 messages? Because we basically created the summary. So let's see in the summary if we have anything. Yes, in the summary we have, sure, in our conversation, you introduce yourself as Giorgio, but mention everyone calls you Giorgio. You then ask all those things. Does this make sense, everyone? So what we have done is when my number of messages exceeded 6, which is my configuration, right? In my conditional node, I have said if my length increases to 6, then I should call the summarize conversation node. And my summarize conversation node is doing what? It is creating summary of my messages, leaving the last 2 messages. That's why when I called it the 4th time, when there were total 8 messages, it took the 6 messages and summarized it and left just the 2 messages in the messages one. Okay, so this is how basically what we can do. We can summarize our past conversations and get going.
And basically, at that moment, it's deleted the 6 messages.
Yeah, it deleted those 6 messages from the messages, and it created a summary and put the summary of those 6 message into my uh,
Summary,
summary
summary
key.
section.
Okay. Now when the user asks again any question, from 2 it will become 4, right? And from 4 it will become 6. Once it again becomes 6, it will again go back to the LLM for summarization, and a summary will be created, and then the summary will be appended to my summary node. And again, in the messages, I will have just 2 messages. So this is how we basically manage by creating the summaries. Okay. So you can play around with this one. I will be sharing this code with you guys. So you can go ahead and make your hands dirty, practice it, learn it. These, I mean, if you learn LangGraph, I think you will be able to learn all the frameworks. You can work basically. You can basically visualize what is going behind the scenes, even if you work on N8N frameworks as well. Okay, so I will stop here today. Anyone has any questions? Feel free to ask.
Surinder, I have
Hanji.
one question,
Mm-hmm.
general kind of.
Mm-hmm.
Suppose same kind of request we can get on further. So can we store these kind of the messages or sequence each and everything in our database? So same kind of question someone ask again.
Mm-hmm.
So we cannot like ask to the any
Hit the
node or
LLM.
anything.
Got it. Got
We
it.
can got it the same memory and we can send to the directly our LLM. Is it
Mm-hmm.
possible?
Yes, yes. I mean, we do accomplish these things by using cache. So this is called cache basically. So
Okay.
what it does is
Hmm.
basically whatever conversations the different users are having with the LLM or any agent is having with the LLMs, if we save them in a particular database, so if the user is asking the same question, what will happen instead of shooting that question to the LLM and incurring some cost of LLM in terms of tokens, I can
Correct.
see, I can check in the cache whether the already same question has been asked or not. If it is asked, then I can pull the reply from there itself. Right? So maybe I can save these in some vector database. Instead of saving them into some generic database, I can use vector database where there will be some similarity search and it will be able to find the answers. Right? So I can, so this is called caching basically.
Okay. Okay.
This is very
Is it
much,
possible? But
yes, yes,
let's
yes,
go.
yes, yes, yes. It is
Thank you.
possible, and and it's also being done in the
Okay.
industry to save the cost from the LLM.
Yeah, definitely. Everyone is looking for the cost saving. Yeah.
Correct. Correct.
Okay. Thank you. Thank you.
So, what is the database you are talking about to store
Vector
the
database. Vector database. I'm talking about.
Okay,
So I think you joined this agentic AI course only. Before that, we talked about vector databases also. So
okay,
these are some special databases. For example, we have Quadrant, we have Chroma, we have
okay.
Pinecone. So these are vector
I'll check.
databases where there will be semantic search. Semantic search in the way, not the keyword search, but the meaning of the words or the sentences which are stored in the database. If a user asks any question, its meaning will be searched with the meaning of these sentences which are there. There is some cosine similarity thing which happens and it will bring those words.
Okay, I'll check it. Thank you.
Yeah. Okay. So there are a couple of more topics like how to do parallelization, right? Parallelization. There is something called human in the loop, right? Because not every time I want LLM to book the hotel, right? In that case, or my agent to book the hotel, because in that case, I mean, it can, let's say, it was not able to understand my requirement or my budget was just 5,000 and it booked a hotel, a room in the Taj hotel, and it paid also. So, so that can be disastrous sometimes. So what I want is I want my agent to prompt me saying that, okay, I have selected the hotel room for you. This is the availability. Do you want, can you enter your credit card details? Then maybe I can put my details, because I don't want to share those details with the agents also, right? So that's why human in the loop is sometimes very, very important. And that is one of the most necessary step as well. I don't want my database to get deleted sometimes if my agent is doing such operations, like, it is removing, or I mean, what I want is my agent should ask the user before taking such actions, right, which cannot be rolled back, or something like that. So that's why human in the loop is important. So we will cover this, how to do penalizations, how to do human in the loop, or maybe couple of other things. Okay.
Yeah, it is being implemented in Watson X Orchestrate
Okay. IBM,
and
IBM Watson X.
yeah, and other product as well, like
Hmm.
ServiceNow and all. Yeah.
Correct. Correct. All right, everyone. I hope everyone is enjoying these sessions. So yeah, I will be.
Yep.
I'm starting my fourth batch, which will be again extensive course from right from scratch. So if you have your friends, your colleagues, your relatives, feel free to refer. Okay. In that course, there will be like 12 to 15 sessions. I will start from what is large language models, how they are trained, all those stuff, all the basic stuff. Okay. And up to the agents, which we are discussing right now.
Sure. So in our next session, we will cover these two for LangGraph itself, correct?
Correct.
Parallelization
Correct.
and human
Yes.
in the middle.
Yes. Yes. Yes.
Okay.
Yes. Okay.
Okay.
And then we may have some project on this agent to, use all these concepts. Whatever concept we are using, I want we should build a project where we are using all
Right.
these concepts, right? Otherwise, they are of no use. So we will do one project in the end, maybe next to
Sure.
next class, where we will implement all those things, these concepts to build an agent, full-fledged agent. Okay?
Yeah.
Chalo.
Sure.
Thanks everyone. If you don't have any questions, maybe we can wrap up early.
Thank you.
Have a great day, guys. Thanks everyone for joining. Bye bye.
Thanks,
Okay.
Anand. Thank you.
Happy Mahalaya to all. Thank you.
Thanks. Thanks. Same to you. Bye.